Hello everyone. On this video we will look at adding and subtracting to simplify whole number expressions. Okay, so to get started on that, we're going to look at the commutative property, and in this case it's the commutative property of addition. Okay, so that's in general a plus b equals b plus a. Okay, so in reality there's no reason to make it super complicated. That just means that when you're adding two numbers, you can just switch them around. Okay, so for example, if you write 2 plus 3 is the exact same as 3 plus 2. Okay, or another example, if you have 7 plus 9 is the exact same as saying 9 plus 7. Or if you have more than two terms, let's say if you have 7 plus 4 plus 5, that's the same as saying 5 plus 4 plus 7, or 4 plus 5 plus 7, or 4 plus 7 plus 5. You can switch them around any way you like as long as it's addition. Okay, if it's addition, you can scramble them around any way you like. That's the general idea of the commutative property. And to help me remember, I often say the commutative property, think of commute, like if you're commuting to work. That means you're moving. Okay, so if you're moving from home to work during your commute, then you can move those around using the commutative property. Okay? Again, that's just my little trick to remember it. All right. Now, we have a commutative property of addition, but note there is no commutative property of subtraction because it doesn't work with subtraction. Okay. Now, it does work with multiplication, and we'll get to that on a later video. But you only have the commutative property of addition. You don't have the one for subtraction. And if you need an example of that, just look at 7 minus 5. 7 minus 5 does not equal 5 minus 7. You get two completely different answers. Okay, so on this side, 7 minus 5 is 2. But on this side, 5 minus 7 will be negative 2, which we'll learn about when we go into positive and negative numbers in a later video. All right, so we're going to go ahead and scroll this up a little bit. Now we look at the associative property of addition, which is really similar to the commutative property, but it just states that if you have, let's say, 3 or more terms, and you're adding all of them, you have a plus b. If you just put parentheses around that and add those first, and then add some number c, you'd get the same value if you add b plus c, and then just add that to the sum number a. Or if you wanted to, you can make it a plus c and then add b to it. So just like with the commutative property, it just means that you can add them in any order you like. Okay, so you can associate these two, your a and b, or you can associate your b and c. That's kind of how I remember the associative properties. Just which ones you're going to associate together. Again, you can come up with your own word games to help you remember. That's just how I happen to remember it, considering my horrible memory. All right, so we're going to go ahead and move up a little bit more. So let's say, for example, if you have 2 plus 3, and you add that together, plus 5, that's the same as 2 plus the association of 3 plus 5. Okay, so looking at it, what's 2 plus 3? 2 plus 3 is 5. So you have 5 plus this 5 here is equal to 2 plus what's 3 plus 5? 3 plus 5 is 8. So 5 plus 5 is 10, and 2 plus 8 is 10. So 10 will equal 10, which is true. Okay, so 10 equals 10, which is true. Okay, and again, it does not work with subtraction. You get completely different answer with subtraction in a lot of cases. But this only works with addition. Okay, So let's say if we have 7 plus 2 plus 8 and 7 plus 2, and that's sum plus 8. Okay, so this one, you have 7 plus 2 plus 8 is 10. Equals 7 plus 2 is 9 plus 8. Okay, so 10 plus 7 is 17. Let me clean that up a little bit. 10 plus 7 is 17, and 9 plus 8 is 17, which is true. Okay, so as long as both sides of the equal sign are true, you know it's fact. All right, so if you are still writing this, feel free to pause it and finish up, but we're going to go ahead and move on to our next page. All right, kind of cover that up because we're going to start little by little. Okay, so now we're looking at translation of terms. So really that's just a fancy way of saying that we're going to turn numbers into words and words into numbers. Okay, so how do you know you're going to use a plus? Well, you're going to use the plus when you see words like, of course, plus, or you see words like added to, or you see the word sum. You'll see that quite often. Or you see the word more than, or you may see the phrase increased by. You see any of those words or phrases, you're going to add. Okay, so what about subtraction? Well, you know you're going to subtract if you see minus, if you see the word subtracted from, or the phrase rather. If you see difference, you'll see that quite often along with sum for addition. If you see difference, if you see the phrase less than, you know you're going to subtract, or decreased by, you know you're going to subtract. Okay, so once again, those are key phrases that you're going to look for to let you know when you're going to add or subtract. Now, when you have numbers that you don't know what they are, we call those unknown numbers variables. And they are usually represented by a letter or in some rare cases a symbol. And that's until we learn what that variable is equal to. That's if it exists. In some cases, it may not have a specific value. Okay, it may be just unknown forever. All right, so for example, if you have x plus 2, well, x can be anything. You can plug in, make x equals 7, then 7 plus 2 would equal 9. You can make x equals 3, then 3 plus 2 would equal 5. You can make x equal 4, then 4 plus 2 is equal to 6. If they don't tell you what the x is, then x has no value, and it just stays x. Okay, same thing here, y plus 8. The variable doesn't have to be x, it can be y. Or you can be 3 plus r. The variable can be r. You have m plus 5, or you can have even n minus 2. Your variable can literally be any letter. Okay, and as you go further into math, you'll even see a couple of Greek letters pop up in there for your variables. Okay, so it can literally be any letter, and all that variable is a number value we don't know. Or in some cases, we don't know yet. All right. So if you are still writing this, of course, feel free to press pause and finish up. But we're going to go ahead and move on to our next page. Move this over here. Okay, so if 7 plus 2 reads 7 plus 2, how does x plus 2 translate? Okay, well, in this case, you can see here, our solution, x plus 2 can read as a couple of things. It can read as a number plus 2, or it can be 2 added to a number. Okay, so here we have some number that we'll call x, and we just add 2 to it. Or it could be a number plus 2. Okay, so of course there are tons and tons of different ways you can say this, but these are the main ones you'll see. Okay, so what if we wanted to translate the following? You have 5 added to a number. You have a number decreased by 4. You have 3 less than a number. And you have 8 minus a number. All right, so what I want you to do is go ahead and press pause and take a few minutes to solve these on your own. All right, so I'm assuming you've paused it and worked it out, so let's go ahead and verify your answer. Okay, let me move that up. So for problem A, 5 added to a number. Okay, so really that's just some number and you're going to add 5. And of course that could be 5 plus x also. Okay, or it could be 5 plus r, or r plus 5, or m plus 5, or 5 plus y. Remember, addition is commutative. So 5 plus r is the same as r plus 5. M plus 5 is the same as 5 plus m. So either way is correct. The only way you couldn't switch them up is, of course, you remember you can't do that with subtraction. But with addition, you can switch those around either way you like. Okay. Now for problem B, a number decreased by 4. Okay, so you have some number decreased by 4. So that's y minus 4. Okay, now you have 3 less than a number. So 3 less than a number, if you have some number that we'll call n, then n minus 3 is 3 less than a number. Okay, and I'll show you a way to think about them. Just a little side note here. Think about having 7 minus 3 or some number. You'll change it up any number you want there. So if you have 7 minus 3. Okay. That is actually just 7 minus 3 is 4. Okay, you know that. Well, 4 is just 3 less than 7. Okay, so all we did here, because we have an unknown, we know that n minus 3 is 3 less than a number. We just don't know what that number n in this case happens to be. And again, you can write n, you can write x, you can write r. It does not matter at all. Okay, the only time it matters is if a specific homework problem tells you to use x as your variable, or to use n as your variable, or to use r as your variable. If it tells you a certain variable to use, then you use that one. But if it does not tell you which letter to use, you can use any one. Okay, so 8 minus a number is the same as this one, but it's kind of switched around. So 8 minus some number, and we'll just use r there. Okay. And again, you can use any variable you want. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to the next page. So now let's bring that down here. There we go. Okay. Now for this example, we're going to use the associative and commutative properties to rewrite and simplify each one of those sums. Okay, so for problem A, you have 2 plus 3 in parentheses, or associated together, plus 7. And for problem B, you have 4 plus n in parentheses, plus 5. Okay, so I want you to go ahead and press pause and try to solve this one on your own. All right, so I'm assuming you've paused it. So let's go ahead and verify your answer. Okay, so for problem A, 2 plus 3 plus 7, that's the same as saying 2 plus 3 plus 7, using the associative property. Remember, when they're all added together, you can add these two first, or you can add two other ones first. Doesn't matter which ones you add first. Okay, so we see here 2 plus 3 is 5. So we have 5 plus 7 is equal to 2 plus 3 plus 7 is 10. So 5 plus 7 is 12. And 2 plus 10 is 12. Okay, now for problem B, it's a little bit different because we have a variable. Okay, so when you have a variable, you can combine all of your like terms. So you have your 4 here and your 5 there, you can combine. You can't combine the n with anything because you don't know what it is. So we have 4 plus n plus 5, let me kind of separate that a little bit, equals, we're going to bring the variable out and we're going to add our numbers. And again, this is something you can do without rewriting it if you wanted to. You can just say 4 plus 5 is 9, and that will give you n plus 4 plus 5, which is 9. This is really just an extra step to show the associative property, but you don't have to do it. All right, so that's how you would simplify those two. Okay? And again, you just combine your numbers and you're good. All right, so if you are still writing, of course, feel free to press pause and finish up. But we're going to go ahead and move on to our next page. If I can get the paper separated. There we go. Okay, so what if we wanted to simplify for problem A? You have A plus 6 plus 4. For problem B, you have 5 plus the sum of 2 plus A. For problem C, you have 4 plus the sum of 2 plus X plus 1. For problem D, you have 6 plus n plus 5, all in parentheses, plus 5. Okay. So again, I want you to go ahead and press pause and try this one on your own. Excuse me. All right, so I'm assuming you've paused it and worked it out. So let's go ahead and verify. Okay, so for problem A, you have A plus 6 plus 4. We're going to go ahead and add those two together. So 6 plus 4 is 10. So that gives you A plus 10. And since we don't know what the A is, that's our final answer. Okay. Problem B, you have 5 plus 2 plus A. Okay. You can't add the 2 and the A together, but you can go 5 plus 2 plus A. 5 plus 2 is 7. That gives you 7 plus A. Or A plus 7. Remember, addition is commutative. You can switch them around. Okay, so for problem C, you have 4 plus 2 plus X plus 1. Again, you can't add the 2 and the X, but you can rewrite it as X plus 4 plus 2 plus 1. Okay, 4 plus 2 plus 1 is 6, so that gives us X plus 6. Oh, 7, sorry. I misadded. And for problem D, you have 6 plus n plus 5 plus 5. Again, you can't add n to any of the numbers in there, but you can say n plus 6 plus 5 plus 5. You're just adding all of the numerical values. So that gives you n plus 5 plus 5 is 10, 10 plus 6 is 16. Okay, and that's how you simplify your terms using adding and subtracting. All right, so hopefully this made sense, and I'll see you on the next video.